We're looking at figure 13.3 on page 258 of your textbook. So let's assume there's a city, and just before the city there's a couple of factories that pollute a certain pollutant. In the textbooks they talk about CO2. It could be anything really. Now the prevailing winds, so the wind blows from east to west towards the city. That means the emitter A is further away from the city than emitter B and or C. So A would have a lesser impact on the city than the pollution from C, because there's time, there's more time for the air to break it down into smaller pieces. There's less time for the pollution from C and from B. So you get a more concentrated amount of pollution from C than from A or B. So now the question is, if we have a cap and trade system and we just put a certain amount of permits that emits CO2, let's say there's 30 permits and we to emit maybe a ton of CO2, and each company receives an initial amount of 10 tons. So each company is allowed to emit 10 tons worth of emissions. Now this might not be good, because the 10 tons emitted by company A is a lot less harmful to the city than the 10 tons emitted from company C or emitter C. Now another thing that might be bad is if emitter A actually has a very low marginal abatement cost curve and they're able to trade, to sell some permits to company C. Let's say they sell 3 permits. Now they have 7 permits. They emit 7 tons worth of CO2, and emitter C has 13 tons of CO2. Now you have a worst case scenario, because now the emitter that has the worst impact on the city has more than the one that does not have a big impact on the city. So there might be, we talked previously about zoning. We could get a type of a zoning in here as well. Just want to clean this up. We could say, for instance, that this zone in which A and B is different from the zone in which C is. We can even split A and B up further and say C needs 2 permits for every 1 permit that A and B needs. So emitter A and B need 1 permit to emit the 1 ton, for example, of CO2, while emitter C needs 2 permits to emit 1 ton of CO2. So automatically emitter C needs more permits to emit the same amount, and therefore that allows for that impact on the city. Now what I'd like you to see here is that in the cap and trade program there's still a way we can deal with non-uniform emissions. You do not have to be able to draw this, because it's not really a graph, it's just an illustration, but you should understand that by using zoning we can address the issue of non-uniform emissions in a cap and trade system.